Welcome back to Carneades.org. Today we're going to be continuing with our series, Dumbfounding Definitions, Dizzying Distinctions, and Diabolical Doctrines, a series sorting through some of the jargon of philosophy. In this video, we're going to be taking a look at what is the Littlewood Ross paradox. Now, the Littlewood Ross paradox, also known as the numbered balls paradox, the infinity paradox, or just Ross's paradox, is a paradox about supertasks. This is similar to Thompson's lamp or Zeno's paradox of Achilles and the Tortoise. All of these paradoxes around supertasks involve a task that requires an infinite number of discrete steps that are undertaken in a continually shortening time span to make their infinite number possible, just as Achilles needs to move an infinite number of distances to catch up with the tortoise, but he's able to do it because each of those are getting progressively smaller. Check out our videos on Thompson's lamp or the paradox of Achilles and the tortoise if you're curious for more on those. Now, for this paradox, imagine that I have an infinitely large jar and an infinite set of numbered balls. All of them are numbered 1, 2, 3, 4, all the way up into infinity. After 1 minute, I add balls 1 and 2 to the jar. After another 30 seconds, I take out ball 1 and I add in balls 3 and 4. After 15 seconds, I take out ball 2 and I add in balls 5 and 6. After another 7.5 seconds, I take out ball 3 and add in balls 7 and 8, and so on. This continues at ever-increasing speeds, so all of those times that I'm doing keep getting halved for an infinite number of balls, which we're able to do because we keep cutting it in half, the amount of time in half. The question is, how many balls are there in the jar at exactly 2 minutes? This paradox is sometimes formulated in different ways. Sometimes it's 10 balls that are added in and only 1 removed. At times there are different amounts of time that we're spacing out between, but the general principle is the same. We have an infinite series of tasks that are being done at progressively smaller and smaller amounts of time, and we want to answer the question, how many balls are in the jar when we are done? So, just to be clear, after 1 minute, we have 2 balls in the jar. We just added in balls 1 and 2. After 1 minute and 30 seconds, there are 3 balls in the jar. We took out ball 1 and we added in balls 3 and 4. At a minute 45 seconds, remembering we're acting at shorter and shorter periods of time, after shorter and shorter periods of time, there are 4 balls in the jar. We just took out ball 2 and we added in 5 and 6. At 1 minute and 52.5 seconds, so half as much time as the last time we did something, we have 5 balls in the jar. We just took out ball 3 and we added in balls 7 and 8. And this continues for an infinite number of steps up until 2 minutes. Now, some would argue that there are an infinite number of balls in the jar, because the number of balls in the jar is an ever-growing series that is trending towards infinity. If our method for resolving paradox related to infinity is to use limits and calculus, the function here trends towards infinity as our time approaches 2 minutes. You might think of this argument as if this paradox didn't have numbered balls, and every time the task was done, 1 ball was taken out and 2 more were added in. It would seem that in such a situation, we would end up with an infinite number of balls because we've done something an infinite number of times, which every time adds 1 ball to the jar. We'll never remove more balls than we add, so the value must be infinitely increasing. However, others would argue that there are 0 balls in the jar because there's a discrete point where every ball was taken out. Another way to think of this is to ask, if there is an infinite number of balls in the jar at 2 minutes, what is the lowest numbered ball? It can't be 1. We took 1 out at 1 minute 30 seconds. It can't be 2. We took that out at a minute 45, etc. And in fact, for every single ball in the jar, we have a specific time that we can point to where it was taken out of the jar. And therefore, no balls can be in the jar because every single ball has been taken out at some point. Both Littlewood and Ross thought this was the correct solution to the paradox. However, the proponent of the infinite answer might respond in a number of ways. For example, they might say, imagine we change the task and say that instead of taking out the lowest numbered ball each time, we take out the highest numbered ball. So we would take out 2, 4, 6, 8, etc. This would mean that the remaining balls are all of the odd numbers, or an infinite amount of balls. The problem here is that this procedure doesn't really seem importantly different from the original procedure, in the sense that we do not remove more balls in this procedure than we did in the other. We remove an infinite number both times. But in this case, we're left with an infinite number, and yet somehow, in the other case, we're not. Somehow the other procedure leads to 0, while this one leads to an infinite number of balls, even though we do the exact same thing exactly the same number of times. We add 2 balls and take out 1 ball an infinite number of times in both procedures. So what makes one of those procedures lead to 0 balls being there, and the other procedure lead to an infinite number being there? Taking this even further, imagine there's an imp in the jar that repaints the numbers on the balls every time you pull one out, switching the order from high to low of the numbers that are currently in the jar. You are not fooled by the imp's trickery, and so you pull out the correct ball every time, regardless of how it's labeled. You first pull out 1, but that's now labeled as 2, leaving ball 2, which is now labeled as 1. You then pull out ball 2, just as you normally would, but that ball is now labeled as 4, leaving ball 3 labeled as 3. It was in the middle, so it doesn't change, and ball 4 now labeled as 1. By the end of this process, the imp will have renumbered all the balls in the jar to be odd numbers, and there are an infinite amount of odd numbers. And so no matter how far you go, there will always be that infinite number of odd numbers remaining in the jar, just as if we went through that process where we split out the odds and evens by taking the highest numbered ball instead of the lowest numbered ball. And yet, all of the balls will have been removed because the actual procedure we did, regardless of the numbering on the balls, was the same as the original paradox, though they're all going to be labeled with unique even numbers. Basically, this creates a situation where the 2 scenarios before, removing the lowest ball and removing the highest ball, are effectively the same. And so, once again, it seems like there should be an infinite number of balls in the jar at the end of this, because there would be an infinite number of balls if we removed the highest numbered ball, and this essentially shows that those 2 situations are identical for all intents and purposes. Now, some have argued that the question is answered by what you are more comfortable with being discontinuous. The total number of balls in the jar, i.e. a number that was going up and up and up and up and up, and then suddenly magically goes to 0 for no apparent reason. Steadily increasing to infinity and then suddenly dropping to 0, or the position of balls which are somehow still in the jar despite having a discrete moment where they were taken out, neither of which seems particularly nice. Now, another concern may be that such a task is even theoretically impossible. We might make a distinction between supertasks that can actually be done, such as Achilles catching up to the tortoise, and those that simply cannot, such as an infinite number of balls going into and coming out of a jar. The latter type creates paradoxes, not because we're misunderstanding this as 0 or infinity, but because it's even in principle impossible. However, this will raise challenges for what makes a given supertask count as impossible, since there are clearly some supertasks, such as moving an infinite number of ever-shrinking distances, that are possible. And so, what is it about certain supertasks that make them impossible and others that make them possible? What do you think? How many balls are in the jar at the end of 2 minutes? If there's more than 1, what are their numbers? If there are fewer than an infinite number, how is this task, particularly the imp version, importantly different from pulling out the highest numbered ball? Or is resolving such a paradox merely a fool's errand, as it's practically impossible to do the task that we're being asked to do? Leave your thoughts in the comments below. Watch this video and more here at Carneades.org. Subscribe, support us on Patreon, hit the notification bell, all those good things if you want to see this video and more. And stay skeptical, everybody.